you've got an inferior machine tool that creates harmonics, vibration, you'll never get a reliable process. You can go and buy the best work holding, the best cutting tools. If you haven't got a stable machine tool, you may as well go and buy a cheap white and a cheap tool, because you won't get the benefits of either.
Welcome to this week's MTD Podcast. In this podcast, we will be discussing what makes the perfect machine tool. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a very proud member of the MTD team. Today, I have the privilege to be joined by two special guests. Firstly, Kasra Maraki, a machine tool creator. Kasra started his career as a machine tool designer, then moved into machine tool R&D. His expertise is in mechanical systems and fifth axis machines, with a number of inventions in the field in which we'll find out more during the podcast. Welcome, Kasra.
Hi, Gio.
Great to have you, Kasra.
Thanks. It's my pleasure to be here.
Today we're also joined and have the privilege to welcome the Swarf guru himself, Mr. Joe Reynolds, Director of MTD CNC with over 25 years experience in the manufacturing industry. Joe's speciality is cutting tools. He had his own cutting tool business before starting and joining MTD CNC. And Joe's regarded by many as an entrepreneur within the industry. Welcome, Joe.
Thanks, Gio. Good to be on, mate.
Welcome, guys. It's a privilege to have you guys on board. We're producing this podcast slightly differently under the current environment which we're in at the minute. So we're all doing this podcast from remote locations. So apologies for any imperatives with the audio. But this is going to be an absolutely fantastic podcast, one that I've been really excited about. So Kasra, let's start with you first, please. Can you tell us a little bit about your background, why you got into engineering, how you got into engineering, and what you actually do now, please?
Well, actually, I started as an apprentice in electronics in a small company, but we had a mechanical shop there. So somehow I got dragged into the shop floor and worked about a year in there. And then I started my own company. And we had a few 3D scanners and CMM machines back then, and we gave services for metrologies. And later on, we started designing CNC routers, especially for woodworking. And then maybe after 6 or 7 years of producing different kinds of 4-axis, 5-axis CNC routers, we started a division especially for metal cutting machines. And here now I am, and I'm actually working as a consultant for different companies when they want to purchase a new machine tool, or whether they want to improve their production system or automation, installing new automation equipments. And also I give consultant and help machine tool companies to improve their new products.
That's brilliant, Kasra. And we'll be touching on a lot of the features which you believe makes the perfect machine tool during this podcast. Now, Joe, can you give our audience a little bit of a background about your experience within the industry, please?
Yeah, just briefly. Manufacturing's all I've done really, but development of products, predominantly cutting tools. Done a lot of machining, CNC and manual. A lot of grinding, again, CNC and manual. I've done some injection molding and rotation molding, doing like process development and reducing tack times and increasing throughput, reducing times, and working with companies, Rolls-Royce, JCB, Ford Motor Company, and I've been in manufacturing all my life. It's about 25 years now, would you believe? I know I don't look that old, but 25 years experience.
No, Joe, thank you. And there's such a strong relationship between machine tools and cutting tools, and the evolution of both of them. They need to be evolving at the same rate. So we'll touch upon that a little bit later on in this podcast. Now, machine tools are referred by some as mother machines. So everything that gets made effectively needs to be made from a machine tool one way or the other. Designing a machine tool, Kasra, I read your brilliant article within the MTD CNC magazine. Now, you were discussing mineral castings. Can you explain the benefits of them, please?
Of course, there are enormous advantages of using this new type of production machine beds. Although there are also different types of mineral casting, such as artificial or natural granite or different types of mineral compounds. But the main point is that this new type of production machine tool bed improves a lot in the terms of rigidity and vibration damping, which can cause to high precision machining and keep the quality of each and every piece that is produced by the machine same over time. And it has also a lot of advantages, such as low thermal conductivity, which can also help the quality of pieces that are produced within the machine envelope over time.
Now, with starting with vibration dampening, this is, in my opinion, one of the key features, and I suppose that goes hand in hand with the cutting tools, Joe, in regards to it would also extend the life of the cutting tools. You know, if you've got the perfect foundation of machine tool, you know, solid construction, vibration dampening, and then obviously that will give you greater tool life longevity. That accompanied with the work holding, obviously, Joe. What kind of issues does vibration give you with cutting tools, Joe?
I'll go one stage further. You know, obviously the base of the machine. It sounds obvious, but that's where the machining process takes part. If you've got an inferior machine tool that creates harmonics, vibration, to be honest, you'll never get a reliable process. You can go and buy the best work holding, the best cutting tools. If you haven't got a stable machine tool, all of that's kind of irrelevant. You may as well go and buy a cheap vice and a cheap tool, because you won't get the benefits of either. So it's basically the machining process, in my opinion, starts with literally 101, you know, the base of the machine tool. Let's get a nice firm, construction of a bed, and there's several different variants of those. And obviously the machining process comes from them. But to answer your question directly, vibration's a tool life killer. You won't get a good stable finish. You won't get repeatability potentially. Your tool life will almost certainly be reduced, as will throughput through the machine tool.
No, it's a good point, and I think it works the other way as well. Through experience I've had in the past, some people will buy the best machine tool, but then they'll overlook the work holding or the cutting tool holders, the cutting tools, and they'll still experience vibration because they're not holding the part securely. So I think that no element within the process needs to be overlooked, and vibration is a massive part of the machining process, and something that all engineers should definitely consider. Kasra, I would assume that when picking a machine tool, and I know that you're a consultant for many companies, it's all dependent on the application and the components, which will determine what's the best machine for the job. However, you know, this is we haven't got the luxury of like giving you a component in this podcast, but if we generalize and we say that, you know, if I was a subcontract shop and I wasn't sure what work was going to be coming through the door from one day to the next, but I knew that I had to invest in a fifth axis machine tool to stay competitive and to win more work, what advice would you give me?
Well, for companies that are working as a job shop, I normally recommend that they go with a mid-range envelope size machine. And it depends, of course, on their budget. So if they're looking for a low budget, then we can scratch out many brands, and also for mid-level budget, we have also some machine tool vendors. But it all depends on the budget level, and for each budget level, you can find at least a few good companies that they can support you and also provide you good machines and good services. So it all depends on the budget and the work envelope size.
Now, Joe and myself recently did a podcast on inventions and innovations. Joe, what do you think about this?
It's a difficult question to answer, isn't it? It's a difficult question to answer. Do you, if you're a startup or a smaller SME, do you go and look for what we would class as mid-range to premium machine tools where maybe you can only afford one? Or is there an argument to buy a lesser machine tool? I don't mean lesser, a more cost-effective solution, whereas maybe you'll get 5 years good production rather than 10 or 15. But it might bring that purchasing decision forward 3, 4, 5 years. So it is a difficult. I know in Europe they think of it a bit differently, but I know here in the UK, a very high percentage of machine tool sales are what would be classed as a commodity machine, a machine that isn't going to last the same period of time potentially as some of the more premium brands, and it's such a difficult question to answer.
Yeah, that's a good point, Joe. I mean, in your article, Kazra, you mentioned that mineral castings also offer longevity of machine tool. You see that a reduction in wear. Is that correct, Kazra?
Exactly. Yeah. Actually, the machine beds are how can I say, wear out over time by being in contact with media, all different kinds of media like coolant, like chips and oils, cutting oils. So it's actually depends on the material that this machine bed is made of, and also, for example, the coatings, the paint that they put on the casting parts, and mineral casting compounds, potentially they have higher media resistance than normal cast iron or stainless steel or steel welded parts and machine structures. So over time, it will save you a lot of money and also keep the machine in a good condition after, for example, a period of 5 or 10 years.
That brings you on to a different point, really, in regards to, there's an argument to say that really you should be changing your machine tool every 5 years to keep up with the latest technology. What would you say to that, Kazra?
Well, actually, I cannot say that's for 5 years, because in our industry there are a lot of things going on, but normally you cannot see many big changes in every 5 years. Maybe in a decade or 15 years, maybe some big changes and big benefits. But if you look at even the electrical components like CNC controllers or servo drives, they don't improve that fast at this moment. So maybe some new features every a couple of years. So I say a good life and lifespan of a machine tool, if it is a good machine, well designed, should be between 10 to 12 years, something like that.
That's a good point. Now, in regards to the mineral casting, you also make a point in regards to the designers. It's really opened the box really in regards to how they can design the casting in regards to the holes for the hosing, etc. And it can reduce that can reduce the cost for production of these machines. Does that mean that the machines are actually cheaper as well?
Well, at the moment, unfortunately not, because yeah, the whole technology is new, and I mean it's not new, but it's not being used much often, so makes it a bit luxury type thing. But at the moment, it costs more. But there are a lot of benefits if you look at it totally. It can be very. How can I say, comparable and in competition with the traditional types of machine bed manufacturing. So for designers, it's actually really fun because you can implement a lot of things, and you can avoid post-cast machining, and it's actually a better option for designers.
Now, Joe, you staying on the theme of fifth axis machines for the moment. You've been looking at a lot of fifth axis machines, Joe, with an horizontal spindle. What do you think of that particular design, Joe? Before we get on to Kasra,
I think it's an undersold configuration. Really, you've got all the obvious advantages. You know, the big one, of course, is the swarf removal. There's certain machine brands where the component, believe it or not, is actually literally upside down. There's no better physical conditions for the machining process. But even if it's in a horizontal plane, you know, on the tombstone, you're still getting better machining conditions than a vertical machining center or a 5-axis, you know, VMC style machine. Obviously, there's payoffs for both, but I think there should be more 5-axis horizontal machines in the market, and I think that's probably something we will see going forward. You know, the post processors are very clever now with the CAM systems. There's no issues there at all now. So yeah, no, for me, they're undersold.
I see more pros than cons, Joe, myself as well. What do you think of this, Kasra?
Actually, I'm completely agreeing with Joe because if you look at the mass production companies, they all go for the horizontal types because the rigidity and the capabilities that you can, for example, put on a tombstone and different kinds of fixturing and also swarf management, it's over time it will save you a lot of money. For example, if you look at grop machines, you can even work on the workpiece upside down. So you can imagine that how easily the coolant and swarf management is possible. So I guess and because of the higher rigidity that the horizontal machines offer, I think over time it's a better investment.
So it's a game changer, effectively, Kasra. You'll see a lot more machines designed in this way, fifth-axis machines especially.
Exactly, yeah. And there are a lot of companies that are changing their designs to horizontals, and most of the mass production machinings, I mean, machines that are used for mass production, they are in the horizontal designs, and you cannot find many vertical types in the multi-spindles and also, for example, in automotive industry where seconds matter a lot, and I think that these horizontals are the next generation of machines that we will see everywhere.
Now, Kasra, you mentioned in your article, sorry to keep referring to it, but you've actually invented certain products yourself. Can you tell us a little bit about some of the inventions and innovations that you're responsible for?
Well, actually, I have invented a couple of mechanical systems, especially for portal milling machines, and for some of them are actually good for be replaced and as an alternative for rack and pinion systems. And these ideas that were actually been built and installed over like 10 or 15 machines from 5 or 6 years ago, they improve a lot of machine life and material wear over time, and it will reduce downtimes.
Brilliant. That's absolutely fantastic. And I'd like to learn a lot more about them inventions, in the future, please, Kasra. Joe and myself, Kasra, had a conversation this morning actually about jerk rates. Now, a lot of people don't. It's one of them subjects. Some people never really understand what they are. Can you explain what they are in layman terms for us, please, Kasra?
Of course. Well, actually, it all depends on the design of the machine and the way of the machine tool designer designed the whole structure, and also how they how can I say it designed the whole mechanical system and to avoid the jerks and to avoid the vibrations throughout the machining process.
Okay, so it's kind of my understanding of it was, Kazra, correct me if I'm wrong, if you were doing, say, for example, an aerospace blade, and when you're going across a flat plane, say if you're going across that flat plane in the y-axis, if you're on a fourth-axis rotary table, whilst you're just going in the Y, you've got a constant feed rate. But then when you start introducing the A-axis, that feed rate needs to change as you're going around the blade. Is that what we're referring to, acceleration and deceleration?
Well, there are a lot of controllers that now they can actually calculate the proper feed rate and the proper acceleration during the machining process and during the cycle of machining. So with the new innovations that has happened in the CNC controllers, you can find a lot of things that are as we can say, fully automated in terms of reducing chattering and reduce the material and tool wear. So as I understand, you're saying correctly, yeah.
Yeah, brilliant. Now, Kazra, I'm going to put you on the spot, but firstly, I just want Joe's opinion on this. We've been having a debate now on MTD CNC for a few months, and it always creates different opinions. Box guideways or linear guideways? Joe, what's your opinion on this? Sorry to put you on the spot first, mate.
Oh, it is a tough one. I know we spoke about the advantages of linear before, but in the UK, I suppose if you're going for a medium, a high range CNC machine tool, I would go for linear in, if not all axes, the vast majority of axes. But there are some good machine tools out there in the UK, very cost-effective solution. You can get up and running straight away, and we do a good job for you over a 5, 6, 10-year period. Albeit, you might get a better repayment long-term buying a premium machine tool with linear guides. But I do still think, there is an argument for a startup company or a company that isn't particularly cash rich to still buy box machines, because there can be price advantages, and certainly in the UK.
Yeah, Kazra, sorry, putting you on the spot too, mate.
Well, my opinion, I guess, but I think that the box guideways are really outdated, and in the near future you cannot find them much often. And I think that mostly the companies that are now using the linear the box guideways, are the ones that have the machining processes and everything on their designing departments ready. And I don't think that in the near future we can see much box guideways, because after some time and over time, you will see that the reduction in precision of the box guideways are a lot, and also it's hard to taking care of them. And as I say, that it's a little chip, and small piece of chips can scratch it for life, and it also needs a lot of adjustment over time. And I think that their time are now going to be over soon. I mean, in the near future, we will have for very high precision machining or very heavy machining, we will have hydrostatics. And for normal applications, we will have only linear guideways, because now with their improvements in the past decades, you can find various types of linear guideways for all different kinds of applications, and they offer high precision and long-lasting life. So I guess they are the better solution to go for if you are planning to buy a new machine.
Right, Kazra, sorry, Gio. What would you say the percentage sales are linear against box within Europe, or maybe even globally as we speak today?
If we put hydrostatic aside, I think more than 70%, 75% are linear.
Wow. Okay, interesting.
And
that
you
is
can find
interesting.
a combination of that. For example, there are some machines that they use X and, for example, for a normal VMC, I'm saying you can find a machine with the X and Y axis linear and box guideways on the Z axis, or vice versa, maybe on the table for, as they claim that it can hold and carry bigger loads and heavier materials. Maybe they use it on the table and linear on the z-axis. But I think that more than 75% are now linear guideways.
Wow. I mean, that's a big percentage. I think that, like, from my own experience, I mean, that for me, the biggest change is the cutting tool strategy is dictated, like we mentioned at the beginning of this podcast. The cutting tool strategies and the evolution in the cutting tools have dictated linear machine tools, because now it's more faster feeds and speeds and smaller cuts. Would you agree with this to a
Exactly.
certain degree?
Absolutely. Now, with the improvement of the strategies, now we are not going to get big bites on the materials. We are just removing material, little material, but in higher feed rates and higher speeds. And now, for example, we can see that we are engaging mostly all the tool length and fewer, how can I say, step overs. And so more step downs and fewer step overs, or smaller step overs, and with a higher speed. So all the different types of strategies that the CAM softwares are offering now, they are going to be higher depth of cut, but less step overs, and higher speeds and higher feeds. So with that, I think linears are a better option, because we are looking at higher speed and higher feeds, and also higher
So,
acceleration.
so it's safe to say that you'd definitely pick linear over box. So,
Yeah, it's not exactly sat on the fence, is he?
no, definitely linear for you, Kazra. Now, the podcast, what makes the perfect machine tool? So, putting aside linear and box, we know your opinion on that. If I was to buy a new machine tool, whether that be fifth axis, horizontal, a lathe, what would you say to me would be the main considerations for me when looking to purchase a new machine tool? What would the key points be?
Well, as I mentioned in my latest article in MTD, it's all about finding a balance between financial investment and technical requirements. So there are hundreds of machine tool vendors all over the world, and they are offering different kinds of machines, and you can find a single product, mostly same, and even in the smallest details they are the same, but the price range are different. So it's all about finding a good balance between your technical requirements and also the availability of the machine, and also, for example, the different costs that it might cause you. For example, to get the machine in your workshop, if it is stored nearby, or if you have to pre-order it. So all different kinds of aspects must be considered. But I would say that if you have a fixed budget, then you have to look for and you're looking for an ordinary machine, for some machine that is mostly common and can be found everywhere. Then you should look for the machine that is available in your area. That's my opinion for most of the conventional machines. Yeah.
Thanks, Kazra.
Sure. Do you have any preference on control, Kazra?
Well, for 5 axis, I always say Heidenhain, of course, and but you can see, for example, in Europe especially, you can find, except Germany, of course, you can find Fanuc everywhere. But in Germany, it's mostly now Siemens and Heidenhain. But it depends on your applications. For me, for 5 axis, personally, I
Germany's
will go
incredible, isn't it?
for
Certain parts of Germany are Siemens and some are Fanuc. It's incredible, Germany.
Hello?
Hello?
Hello, Joe?
Yeah.
Oh, sorry.
Yeah, sorry. Sorry, you broke up there. No, I was just saying, in Germany, you've got big pockets of Heidenhain and Siemens users in Germany. It's it's that the location seems to count for a lot in Germany.
Yeah. It depends actually on the location, and also, for example, in Italy, you can find a lot of Italian brands. For example, like Fidia, Tex Computer, Promax, the Electron. So there are a lot of controller manufacturers in Italy, and you can find them on many machines like Ozai, which is really famous actually. So and also it depends on your application. For example, for milling machines, for turning machines, for plasma cutting, for laser cutting, for woodworking. So each and every of these controller manufacturers are expert in some specific field. It's not like Siemens or Fanuc that you can find it on most of the applications. Of course, being everywhere doesn't mean that you are perfect in every application. For example, Heidenhain is only focused on 5-axis milling machines mostly, so they are perfect in that. And but for example, for woodworking, most of the companies go with Ozai, or for example, for how can I say, for laser cutting, there are a lot of companies that are going for Ozai because they are good in that field.
Kasra, is the programming language as important as it once was many years ago? I mean, when I was on the shop floor programming components on the ductboard, programming directly into the CNC machine, it was imperative that you had a good control system because you wanted it to be as user-friendly as possible. However, now with some of this complex machining, it doesn't ever, a lot of the time, it doesn't ever get programmed on the machine. It gets programmed offline. So is it just about now, or more so, the processing speed?
Well, actually, the CAM softwares now are offering a lot of features and also very good simulations. So with the good simulation, you can see basically what's going to happen in your machine. And I think it's essential that you know a basic knowledge of G codes and M codes, and of course different kinds of codes that you might need. But with complex machining, you cannot do it, manually, but just typing some points and numbers on the control panel, and for example, want to machine an impeller or blade or something like that. So I guess that's now it's basically based on your software knowledge and software skills.
Definitely. Well, it's been an absolute pleasure to have you join us on this podcast, Kasra and Joe. Any last thoughts before we go?
Nothing really. Just it's been a pleasure being here with you and having this amazing talk and interview. And I'm absolutely a big fan of all these kinds of podcasts and audio contents. As earlier, I was talking to Will about them, and I appreciate your work. Thanks a lot.
No, thank you, Joe. Any last thoughts, my friend?
No. Thanks for your time, Kasra. And like you said, you've kindly done a piece in the March issue of the MTD magazine that is available online. If you're one of the few that don't have a hard copy, go to mtdcnc.com and you'll find it on the navigation to the magazine. Can't miss it.
No, thank you very much, guys. It's been an absolute pleasure having you both on board. If you've got any questions about this podcast, don't hesitate to contact MTD CNC. You can also find Kasra on LinkedIn. Is very active on LinkedIn, and I'm sure he'll be able to help you with any questions that you may have or any solutions that you're looking to solve. I hope you've enjoyed this podcast from MTD CNC. Make sure to subscribe, comment, and tune in on your iPhones so you don't miss any future episodes. Everyone stay safe, and until next week, the MTD Podcast.
Thanks for listening to the MTD Podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.